Hello and welcome to the second session on the topic of weather hazards and climate change. This session is going to be building on your knowledge from last lesson, which looked at atmospheric circulation, so the movement of air in the upper atmosphere through things like circulation cells, Hadley cells, Ferrel cells, polar cells, and also how it's affected by things like the Coriolis force and jet streams. But for today, we're going to be looking at the other thing that can affect air a bit closer to the surface of the Earth, and that is the oceans themselves. So oceanic circulation and its role really in how it affects global climate. So specifically, what you're going to be investigating is how certain ocean currents, and you will identify and need to know where the Gulf Stream and the North Atlantic Drift are, but also know what they do to certain areas. So we're going to specifically focus on how these ocean currents bring rainfall, but also warm weather, unseasonably warm weather, to the United Kingdom, based on where our latitude is. So once you've got the title written down, please make sure you then carry on to the next slide. Okay, so here is a familiar face from the film of Finding Nemo, and you might recognise him. If you haven't watched the film, it's great. Now, he is known for travelling in the EAC, or the East Australian Current, and the East Australian Current, unsurprisingly, you will find off the east coast of Australia. And it's like one of many ocean currents that circulates around the world, and these ocean currents, on a large scale, actually combine to form something called the Ocean Conveyor Belt. Now, the Ocean Conveyor Belt is a mixture of lots of different currents kind of joining, but effectively, water circulates around the oceans across the entire planet, and it does it at the surface, but it also does it really deep down below too. And we're going to investigate a little bit more about what those ocean currents do with regards to our climate and how they affect our climate. So it's all about motion in the ocean, and this video, which is saved onto 365, and if it's not, please feel free to just copy that YouTube link down. I'm hoping it still works, because it's absolutely fantastic. This is an excellent video to explain how ocean currents move and work, and more specifically, it talks about the Gulf Stream. Now, you need to know about the Gulf Stream because they name it in the exam board specifications, so there's every chance that it'll come up in an exam paper as a specific part of the topic. So I'd urge you to watch this video. It explains it better than I ever could, and the image you can see, the diagram, shows you just in general that ocean conveyor belt where the red line is a warm current and the blue line is a deep water, so a current that's sunk down that's much colder, and it'll explain how and why these streams move. Okay, now I cannot express enough how important it is to watch this video, so if you haven't got the link, or you can't get the link from 365, do type in this YouTube video, okay, and it will work. I will check it, but I'm sure it will work. Okay, so why that's important. Now, hopefully you've watched the video and you've got a really good understanding of this ocean conveyor belt. The Earth's major oceans, and this is me sort of summarising that video, transfer water through this linked system of currents, which we call the ocean conveyor belt, as I've mentioned. Now, the UK specifically benefits from that, and the Gulf Stream and the North Atlantic Drift are the two currents that we really want to focus on. And to highlight this, in terms of our latitude, so our distance above the equator, the UK is 51 degrees above the equator. The equator is 0, okay? So the higher that number, the further away from the equator you are. Now, because we're further away from the equator, you should know by now that it gets colder the further away you go, because the Earth is curved and the solar radiation is more spread out. Now, 51 degrees is by no means the North Pole. The North Pole is 90 degrees. The actual magnetic North Pole, the geographic North Pole, 90 degrees away from the equator. And we are 51 degrees. So we are more than halfway away from the equator. We're closer to the North Pole, geographically speaking. So you can expect that to be quite cold. And, the UK is a chilly place at times. Canada, and Toronto specifically in Canada, Toronto's latitude is 43 degrees away from the equator. So it's 43 degrees. So it's closer to the equator than we are in the United Kingdom, in London. And it's quite considerably closer. It's actually closer to the equator than it is the North Pole, whereas we are obviously closer to the North Pole. I know it's a small amount of degrees in it, but it makes a difference. And that's reflected completely differently by those temperatures that I've put on the board, on the screen, sorry. The January temperature, the average January temperature in Toronto in Canada is minus 5.8 degrees Celsius. Now that'll change from year to year with global warming, but minus 5.8 is the average January temperature in Toronto. The average January temperature in London is 4.3 degrees positive. So what we are looking at is a shift of 10 degrees Celsius difference, even though we are closer to the North Pole than Toronto in Canada. Now the Gulf Stream and the North Atlantic Drift are why that happens, and that's really, really critical to understand. We are far warmer than we should be just based on our latitude alone, and that's why this shows you the importance really of this ocean circulation and oceanic circulation. So here is a bit of an illustration of that, and again the video did sort of hint towards this, but the Gulf Stream, which is formed around the Gulf of Mexico, you'll see just off the east coast of the United States of America, North America, you can see it starts basically at the equator, that white dotted line across the middle. Now, water at the equator, understandably, because it's next to the equator, is warmer. And that warmer water can hold on to its temperature much longer than air can and land can. Solid things like land, solid surfaces, heat up quicker and cool down quicker. Whereas water takes longer to heat up, but it also takes longer to cool down once it's hot. The best explanation I can give of this, analogy-wise, is a cup of tea. If you make a cup of tea, you boil the kettle. It takes a few minutes to boil that water from cold. You then pour the water into your cup, and if you drank it straight away, you're going to burn your mouth because it holds on to that high temperature that it's taken a little while to get to. And in fact, to get back to being cold again, a cup of tea will take 10 minutes. Now, if you get a teaspoon and you stir your tea bag or your milk or your sugar or whatever you put in there, it only needs to be in that hot water for a matter of seconds before that teaspoon is so hot it'll burn you on your skin. But if you take it out of the tea, give it 10 seconds rather than 10 minutes, and it's cold enough to touch. So land is like the teaspoon. It will cool down and heat up far more readily, whereas liquid, the properties of liquid, like the oceans, apologies for the bell in the background, the properties mean that it takes longer to cool up, but it also takes longer to cool down. So as the Gulf Stream heats up and then moves northwards and forms the sort of the North Atlantic Drift, what it does, it brings with it warm water. Now I'm not talking bath temperature, but it is warmer than the surrounding air should be, and we feel it in the winter rather than the summer. Because in the summer, we've got better temperatures because we are tilted more towards the sun in the northern hemisphere. So let's take in the UK, we experience much better weather and much warmer weather in the summer months because we are angled more towards the sun, and therefore we are we're a bit nearer to the equator, but not really, but in terms of the properties of being tilted. But in winter, we're tilted away. But even though we're tilted away and therefore we get colder temperatures, we also get the benefit of this Gulf Stream and the North Atlantic Drift, because that is like a little radiator and it heats the air above it. And the air that goes across the United Kingdom is much warmer because of that. And so because it blows across us from the southwest, which is where the North Atlantic Drift kind of travels towards, we are able to benefit, and you've seen it, by 10 degrees difference to Toronto and Canada, we're able to benefit massively from that extra warmth. So that's a great thing. In our winter, we do not get extreme winters like you might find in places like Canada, because Canada don't benefit from that warm air blowing across them. In fact, Canada have a problem entirely. They are a big continent with a large landmass. Canada are the teaspoon. We are an island surrounded by hot tea. That really is the principle I'm trying to kind of get you towards. So the UK, even though it's quite far north, does massively benefit from this warm ocean surface current. Now, what happens once it passes us, the North Atlantic Drift? It actually goes up into sort of near the North Pole, cools down, becomes more salty, more saline, because as it's warmer, more moisture evaporates, making it more salty. And then because it's denser, because it's colder and more salty, it's heavier and it sinks. And then it becomes a deep ocean current, it gets really cold and it starts to go back south again. And that then completes part of that little part of the ocean conveyor belt and travels all the way down, again around the world in the ocean conveyor belt. But all the while, we're getting this constant stream of warm water from the Gulf Stream. And like I said, in the summer, we don't really feel it because our latitude is such that it benefits us in the tilt of the Earth. But in the winter, we really, really notice it. But not only do we get the warmth, the fact that we've got moist air blowing across us from the west from a large ocean also brings us rain. And we do get our wettest weather in the winter months as well, particularly the west of the UK. So it brings us both warmer temperatures, but also it brings us more moisture, more precipitation. So again, really key there, just how important, just to the UK, but also globally, this is happening everywhere, how these ocean currents can really affect our climate, and that 10-degree difference between us and Toronto is really a highlighting factor of that. Okay, so the task really, and this is just a task, I really massively want you to identify the Gulf Stream and the North Atlantic Drift, but if you could just get an idea about the overall conveyor belt motion, that would be really handy. So if we looked at sort of the previous slides, this one, if you kind of got this idea overall, that would be ideal. And again, you can see on the top left hand side, you've got that Gulf Stream, that red one coming up north past the UK. Okay, so that is the end of this session. So I know it was a short one, but now you've got two very distinct reasons why global systems, in terms of atmospheric circulation and oceanic circulation, and about how they can directly affect the climate of places, both in terms of temperature and levels of precipitation. Okay, so well done for getting through lesson 2. I'll see you next time for session 3. Thank you for listening.